Hello everyone, Cody here, and today we're going to be talking about convolutional neural nets, fully connected layers. Now it's going to be a pretty quick video because it's just a high level, and the fully connected layers is kind of, once it's described at a high level, getting into the weeds is where it becomes a little more complicated. But essentially, you have these, convolutional layers, then you have the pooling layers, and then you have this fully connected layer. And the pooling and the convolutional layers can go back and forth, kind of filtering. If you're thinking of it like a funnel, it may start looking exactly like the exact same amount of pixels as the initial picture. And then as things go on, it just kind of keeps getting shorter, um, both width and height wise, but then it's quote unquote depth starts becoming a little bit different because you're summing up all these numbers because you're basically doing vector multiplication across multiple different, feature mappings and different types of pooling layers and all this jazz. So the fully connected layer is basically taking all of those, hidden inputs and turning them into a probability or predictability for which depending on your depending on your problem, which type of output is going to be the most likely. So to give you an example, if you're using the Mint's handwriting technique where it's figuring out digits from 0 to 9, you would have that many different classifications to go through. So you'd have a 0, 1, 2, 3, 4, 5, so on. And the flattened layer would take all of the kind of mathematically readily handy information that happens when you're making layers in max pooling or summing pooling or average pooling, and it essentially just makes it into a one-dimensional uh, number. So instead of having a whole bunch of data that's just sitting there waiting to be used again conveniently for the next layer that's either convolutional or pooling, the fully connected layer goes through a process of squishing or flattening the math and turning them into simply just like probabilities of that are much easier to understand from the standpoint of like you and I being able to predict it. And that's essentially it. Now with Keras, which is a library that I'm still exploring, with Keras, dense is, from my understanding, a simpler version of fully connected. It has some things that may not necessarily be 100% true to fully connected, but when I've done a handful of convolutional neural nets with using dense as a fully connected layer, it seems to work perfectly fine. So once again, just high level, the fully connected is the end cap for a CNN to take the mathematical equations that are conveniently left kind of in their slots so that they can be switched between convolutional and pools, and flattens them into the different types of classes. So it kind of takes it all and just, I believe the technical term would basically just be like multiplying them across and then giving them one sum number across all of that instead of having a handful of different numbers based off of the dimensions and the stages that you're at with the pooling. So why don't we go ahead and do an example CNN